Okay, we are on our last lesson of Chapter 11. It's going to be over rational equations and functions. We're being asked to solve some more equations through proportions. So let's get started with this one. We can use cross products to solve this. So let's go ahead and do that. X times x minus 4 should equal 3 times 4 if this proportion is true. So we'll distribute the x. Simplify the right side, and then put this thing in standard form by subtracting 12 from both sides. Now we've got some options when we've got a quadratic equation like this. I'm going to look to factor it if I can because the lead coefficient is 1. It is factorable. Negative 6 times 2 is negative 12, and negative 6 plus 2 is negative 4. And then we can use the zero product property to solve this. The one thing you do want to make sure is that neither one of these solutions is extraneous, meaning we can't have a denominator that is 0, but 6 minus 4 isn't 0, and negative 2 minus 4 isn't 0 either. So both these solutions should work. All right, let's do another one. We can't do cross products here because we got this addition over here. So instead what I'm going to do is look to get rid of the denominators. I'm going to multiply each term by the least common multiple of the three terms. So the least common multiple of the three terms is 15x. So I'm going to go ahead and multiply every single term by 15x. And then when I go ahead and simplify each term by multiplying, first one, the 5's and the x's cancel out. You're left with 2 times 3 is 6. On the second one, the 15's cancel out. You're left with negative 3 times x is negative 3x. And on the third one, the x's cancel out, so you're left with 1 times 15 is 15. Then we've just got a linear equation that we're going to solve, and that should be pretty quick for most of us to subtract 15 from both sides and then divide both sides by 3. Again, I would check for extraneous solutions, but plugging 3 into any of these denominators is not going to make it 0, so x is the value that solves this equation. I'm sorry, 3 is the value that solves this equation. All right, let's do this again. Again, because we have this addition over here, we can't just do cross products. So what I'm going to do is look to multiply everything by the least common multiple of the denominators. That's going to be easiest, though, if we first factor this quadratic trinomial over here. Negative 7 times negative 2 is positive 14, and negative 7 plus negative 2 is negative 9. So now it's going to be easier to identify the least common denominator, or the least common multiple here. That would be x minus 7 times x minus 2. So we'll take the first term and multiply that by x minus 7 times x minus 2. And we'll take the 1 and multiply by x minus 7 times x minus 2. And we'll take this 8 over x squared minus 9x plus 14 and multiply it by x minus 7 times x minus 2. Okay, simplifying here, the x minus 7's cancel out, and I'll distribute the 3x minus 6. Over here, we've got a FOIL pattern, so we should have x squared. Then we've got negative 2x and negative 7x makes negative 9x and positive 14. And over here, pretty much everything cancels out except for that 8. So we've got a quadratic equation. Let's put it in standard form. Combine like terms on the left side. Let's subtract 8 from both sides. And then probably the easiest way to solve this equation is to factor again. Let's factor out a greatest common factor of x, and then use the zero product property to say that our solutions are 0 and positive 6. Again, you want to make sure that you have solutions that do work in the original equation. This one should be fine. All right. How about graphing rational functions? Now that we've solved some rational equations, let's graph some rational functions. A couple key things we got to talk about here first. First of all, the graph of a rational function in this form, y equals a over x minus h plus k, is called a hyperbola. We'll see what that looks like in just a second, whose center is hk. So whatever number is being subtracted here is the x value of the center, and whatever number is being added here is the k value of the center. Okay, the vertical and horizontal lines that run through the center are called asymptotes of the hyperbola. An asymptote is a line that the graph approaches more and more closely. It is not part of the graph. Okay, so what we've got here, this is our hyperbola. Well, these are the branches of our hyperbola anyway. This right here is our center, hk. And these dotted lines that are not part of the graph, but the hyperbola is approaching them but not touching them, are called the asymptotes. Go ahead and have a little giggle if you want to. All right, so let's try and graph these. First of all, we need it to be in the form of a over x minus h plus k. Sorry, let's fix that. Which this is. So now we can easily identify the center as 1, that's h, and k is 3. So let's plot that point. That's our center, and these are our asymptotes running vertically and horizontally through it. Now, to figure out where the hyperbola falls, we're going to just plug in one value of x just to kind of get a rough gist of where this falls. So let's just plug a number greater than 1 in, like 2. That'll be the easiest thing to do, trust me. Just something 1 greater than that x value. So we're going to do y should equal 2 over 2 minus 1 plus 3. All I'm doing is plugging an x value, 2, into the original equation or function. So there we go. What we get is that when we have an input of 2, we have an output of 5, and we can plot that point. Now we know where the hyperbolas fall. We're not going to get too complicated with this. You'll get into it much deeper in advanced algebra come high school. Let's just go ahead and do a very rough sketch of these hyperbola. There's one side, and the other side should be symmetric to it. It's on this side. Okay, and the reason we had to plug in one value so we knew that it fell here and here instead of the top left corner and the bottom right corner. So there's always two possibilities. It could be here and here, or bottom left and top right. Well, let's graph another, and maybe you'll see the pattern a little bit better. So it's got to be in the form of a over x minus h plus k. This one's not quite. This is not minus h, it's plus 2. So how about we just make it minus negative 2. Now we can see that negative 2 is the h value, and negative 3 is the k value. Okay, so we'll plot that point, make our asymptotes, and then let's just plug negative 1 into this equation. I'm sorry. Let's plug, yeah, negative 1 should work fine. Plug negative 1 in there. And see, that gives us negative 1 over 1 if we just plug a number 1 greater than negative 2 in. And now we've got an input-output. So when we input negative 1, we get an output of negative 4. Plot that point, and now we can see where our hyperbola is going to fall. Right here, and then symmetric across the center, right here. Not perfect, but good enough for what we're doing right now. Like I said, you'll get into this more in advanced algebra. We're just going to do some rough sketches here. All right, one more. It's supposed to be in the form of y equals a over x minus h plus k, but this one is not in that form. So what we're going to do is do some division here of polynomials, which we've done this chapter. So we'll actually do 2x minus 1 divided by x minus 2. Okay, so what I did here is what number times x would give us 2x. Obviously that's 2. And then I'll take this 2 and multiply it by this binomial. 2 times x is 2x. 2 times negative 2 is negative 4. And then we subtract. 2x minus 2x is 0. Negative 1 minus negative 4 is positive 3. And then we get a remainder of 3 over x minus 2. So now we've got it in the form of a over x minus h plus k. I just flipped these around because addition is commutative. All right, so our center should be 2, 2. And then we'll plug, well, we can plot our center and make our asymptotes. And then we'll plug, say, a 3 in here. So we can get an output of 3 plus 2 is 5. So plot that point. Input 3, output 5. There's one branch. Here's the other branch of our hyperbola, and good enough. You know, if we wanted exact values up and down this hyperbola, I would use a graphing calculator, quite frankly. It'd be the easiest way. All right, so there's a very light introduction to graphing rational functions, and also we solve some rational equations. Give your book a little read through. This section starts on page 690, and come into class tomorrow ready with your questions. Good luck.